Hello everyone, today we are going to perform simplex method in MATLAB. This is our course project guided by Dr. Pulikishore Kumar sir. So before going to the topic, let me introduce myself. I am G. Hemachand from ECE department in NIT Andhra Pradesh. Okay, let's have a small introduction about simplex method. The simplex method is widely used algorithm to solve linear programming problems. It starts with an initial feasible solution and improves the solution by moving along the edges of the feasible design. The simplex method is basically used for both maximizing or minimizing the objective function. This method will terminate when no further improvement can be made in the problem, and we can get the optimal solution at the vertex of the feasible design. The simplex method is also used in both linear and non-linear optimization. So as we know, this method will plays very important role in the day-to-day life of an engineer. So let's solve a simple problem from the VLSI industry to have more understanding regarding the simplex method. Okay. Here you can observe the question which states that a VLSI company produces three types of MOSFETs. They are A, B, C. The profit for each MOSFET were given, and the requirements amount of the required amounts of the raw materials were also given. Here the raw materials are polysilicon, metal, and substrate. And this company has 4 units of polysilicon, 5 units of metal, and 6 units of substrate available for production. The type A, the type A MOSFET requires 2 units of polysilicon, 1 unit of metal, and 1 unit of the substrate. And type B requires 1 unit of polysilicon, 3 units of metal, and 2 units of substrate. And finally, the MOSFET of type C requires 2 units of polysilicon and 1 unit of metal and 2 units of the substrate. So here we need to find the number of MOSFETs need to be produced by the company to maximize its profit. So our first step is to find the equations and constraints. From the question we can find the objective equation as 3x1 plus 3x1 plus 4x2 plus 5x3. Here x1 is the number of MOSFETs produced of type A were produced, and x2 be the number of MOSFETs of type B, and x3 be the number of MOSFETs of type C. So subject to the constraints. The constraints are the polysilicon constraints, metal constraint, and substrate constraint. Here we can now we need to reduce we need to remove these inequalities. So to remove these inequalities, we need to introduce the slack variables in the equations. So the slack variables are S1, S2, and S3. Okay, slack variables. So when our next step is to write the iteration tables. So these are the basic variables, these are the total variables, and this is the minimum ratio denoted with theta normally. And we know the normal method of solving this iteration table. Similarly, we need to perform iteration 2 and iteration 3 till we get the non-negative values in Cj and Zj minus Cj. So we know this method. So our motto is to solve the problem using MATLAB. So we need to write a MATLAB code to perform all these steps. So in the final step, as Zj minus Cj is greater than or equal to 0, we will get the optimal solutions at the variables x1 is equal to 1, x2 is equal to 0, and x3 is equal to 2. And the maximized value is z is equal to 30. So now we will solve the above problem in MATLAB. Okay. This is the algorithm to solve the problem in the MATLAB. First of all, we need to convert the inputs and constants into vector form, and we need to then set up an initial W, and we need to perform the simplex algorithm using the code, using various functions and using various functions. And we need to find the leaving variable, and we need to update the table, and then we need to extract the optimal solution and objective value. So let's see the code. This is the MATLAB code. Let me zoom it. Okay. Our first step is to define the constraint matrix. The constraint matrix is here defined as A, and then we need to define the right hand side of the constraints. These were defined in B. We need to define the basic variable indices. The basic variables indices were also defined in this form. Indices were used to these indices were used to denote the slack variables. So we need to define the ease maximization or ease minimization condition. So we will get the maximized output if ease max is true, and we will get the minimum value if ease max is false. Okay? So initially we need to solve the problem by creating an initial table and equating. Here the initial table is created by taking A, I size of A comma 1, B, C, and zeros of 1 comma size of A comma 1 and zeros. So we need to begin the simplex algorithm. When t n when t n is less than 0, we need to determine the entering variable. Similarly, we need to determine the leaving variable when this ratio is minimum. So ignore the negative or 0 in this. And then we need to update the basic variable indices. BB row is equal to column. So we need to perform row operations, and then finally we need to display the solutions. So the solutions were displayed like this. If ease max is equal to true, then we will get the maximum value, and if ease max is equal to false, then we will get the minimum value. Okay. Okay. Let's see the output of this code. The output. This output. This is the final output of the above problem, which was solved earlier by us. So this is the maximum value. This 13 is the maximum value, and here x1, x2, and x3 are the optimal variables. So okay, like this we can solve this problem in simplex form. So there is a rise of a query that what will happen if the constant equations has greater than and equal any constant. So let's change this constant into greater than constant. So we need to write a MATLAB code which converts all the constraints into a standard form. So all the constraints need to be in less than or equal to form to solve this simplex problem by using this code. Okay. So let me show you the code. So this code is similar to the previous code, but one step is added. That one step is defining the inequalities. We can define the inequalities by using 1 and minus 1. So, and we need to, after defining, we need to express the codes into standard form. Okay. After doing this, we will get an output value. Here, the output value is same. This shows that in this specific problem the constraint won't affect the maximum value of the problem. It can be either maximum or minimum. So our next step is to generalize the MATLAB code for the simplex one. Okay, we solved this problem, but we need to solve further problems by using this simplex code. We need to solve any type of problems regarding this. So for that we need to generalize a code and create a function. So let me show you. Okay. So we need to write the problem like this, and we need to solve it. Here we can change the values as per our wish. So creating an initial table, these steps are very similar to our previous code. Okay. Okay, by using this code, let's solve another problem. Okay, let me solve a six variable simplex problem, subject to six constraints. So here 4x1 plus 3x2 plus 2x3 plus x4 plus 3x plus 5x6 is our objective function. We need to subject these constants. So you can pause the video and you can note down the constraints and equations here. Okay. So from this code you can do more both maximization and minimization. Okay. So to maximize this problem, we need to give the inputs like this, and we need to check whether we require maximize. We need to check inequality. We need to check the inequalities, and we need to call the simplex algorithm code. This code was written in the previous step. So like this we can define the maximization problem, and here we can solve the same code is converted into minimization problem if ismax is false. Okay. So let's see the outputs of this code, this problem. So finally we got the values of the maximum value. The maximum value of the six variable simplex problem is 24.5 and the minimum value is 0. Like this we can solve various problems using this code. Okay. Okay, we are here in MATLAB platform to see the working of the codes. So this code will solve our first problem, which is not a generalized problem. So let me run this code. Okay. After running, we will get the output. It is showing the x1 value, x2 value, and x3 value, and also the maximum value. So now let me show you the code here. So this is this is the generalized code used to solve the simplex problem. Okay. Now let's test this code by using the test code. The test code here is to solve our second problem, the six variable problem. So here I have kept is max is equal to true. So I will get the maximum value. So let me show you. See here, you we are getting the maximum value. The maximum value of the problem is 24.5, which was seen by us earlier. So now what will happen if is max is false? Okay, let me show you. F if A is false. Okay, let me run this code. After running, we will get the following output. So we will get the following output. The minimum value is 0. So like this, we can write various types of answer. We can solve various types of problems. Let me ask you a simple question. What will happen if we keep minus 4 instead of 4 here? If we keep minus 4, then we need to convert this minus 4 into positive by multiplying with 1. After multiplication of 1, we will get the greater than inequality. Like this, to solve this greater than inequality, we need to multiply with minus 1. So this code will not able to solve this kind of problem. This is the drawback of the simplest code written by me. So the bigger method is used to solve this kind of problems. Okay. Okay. This is the only drawback. Okay. Now let's see the few more applications of simplex algorithm. The simplex algorithm is used in transport logistics, structural design, network optimization, and energy systems and chemical processing. Not only this, the simplex algorithm is used in various departments of engineering and in various fields of research of engineering. So
That's all about the simplex algorithm using MATLAB. Finally, we came to a conclusion that we can solve the simplex problems in standard form by using this code. The, these are the references taken by me to solve this code. Thank you.